Hello. So this time we're going to continue on the conversion of a non-deterministic finite automaton to an equivalent and deterministic finite automaton. And well, here I have a picture that I'd like to just present in a second for you to consider. It contains a sensible number of states so that we can see the whole process. And well, we have to keep in mind two primary questions that we'd like to address as we have developed the procedure. The first one is for any given state, what states can be reached reading a single symbol? So if we look at, for example, state 2, we see in this example that we can only reach state 4 by reading the symbol B, as opposed to, for example, state number 1, which upon reading symbol A, we can either reach 4 or state 0. Good. So let's begin. Now, the only place where there's a real difference is this initial state, because the first question makes no sense. We are not reading anything yet, so it's only the second one that is relevant for our situation. So let's start. Question. What are the things that we can reach just from the beginning without reading anything? Meaning, what are the epsilon arrows that we can follow from the initial state? So, what are the things that we can do? Well, just signaling here, we can stay at 0. We can jump to 1. We can jump to state 2. And we may also, from 1, jump to state 3. Now, how do we signal that? We would say that the initial state of this new machine that we are building as an emulation of the non-determinism would have the following initial state. So the initial state would be something along these lines. The state comprising 0, 1, 2, and 3. And I'll argue once again, why is this? Because those are the things that we can reach without reading any symbol from the initial state. We can stay, we can jump to 1, we can jump to 2 following this arrow, or we can jump to 3 by following this and following that. See, we're not reading anything at any moment. We're just asking what are the things that we can jump directly. Okay, now, this is going to be our initial state because that's where we can start. So I'm going to signal that. Right? And then I'm going to ask a question, right? And I'll start because now I can actually read something. So I'll start by reading an A, right? And I'll put this in writing so that it's a little bit easier for us to follow. So, reading an A from either 0, 1, 2, or 3 results in this. Right? We'll try to organize it, and then we'll see, okay, if we're at state 0, right, we see, well, what happens if we read an A? Well, actually, nothing, right? We land nowhere by reading an A. There's no instruction for reading an A. So let's just signal that with a mark, with a cross. From 1, right, from state 1, which is just indicated here, what happens if we read an A? Well, if we read an A, we can land at state, well, 0. Or we may also land at state 4, following the picture. And well, that's about it. That's all the things that we can do, staying on 1 and reading an A. Okay, well, let's continue, right? Now let's cover this one. What happens if we are at 2 and then we read an A? Well, from that one, well, there's absolutely nothing that we can do, right, as we can see here. What about the state that we signal here as 3? Well, from 3, if we're staying at 3 and we read an A, well, we can land at 4, and that's actually the only thing that we can do, and then we signal it here. Okay. So now, meaning that when we are in any of these states that we're here, right, we can land at either 0 or 4, right? Okay. So then we see, okay, well, but then what happens, right? From any of the states that we have here, 0 or 4, what can we do after that? I mean, we're done reading. Can we jump? Or do we have to stay there? Well, let's signal that. And I will say, well, from 0, and now I'm referring to question 2, right? Without reading any symbol, what could happen? Well, we can stay at 0, or jump to 1, or 2, or 3. Now, from 4, what can we do? Well, without reading any symbol, well, we can stay at 4, or we may jump to 3. So let's put it all together, right? In a single sentence. From either 0, 1, 2, or 3, we can reach by reading an A. What states? Well, I'm going to put them in a list, and then we're going to simplify that list. Those are the things that we can get. We can get to 0, to 4, to 0, 1, 2, 3, or 3. The ones that we obtain by looking here, 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 well, here, 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 and here. But that simplifies to this, which are 0, 1, 2, 3, 4. Okay, so now that is going to make a progression towards the machine that we are building, and we'll make it now a little bit more explicit, and we'll have it just right here. So what is the new picture that we get? Well, we get something along these lines. We have this initial state of 0, 1, 2, 3. Upon reading an A, right, we can get to 0, 1, 2, 3, and 4. Okay? Now, the original machine contains 4 as a final state, so we should signal that the state that contains a 4 in the sequence that we're describing in the set of states is a final state. So as this one is initial, right, this one reads an A, this one becomes final. Why? Because it contains the final state 4 of the original non-deterministic finite automaton. Okay, so we have a portion of our diagram. We're going to continue in the same fashion. Now let's see what happens. What is the thing that we get by reading a B? So now, reading B from either 0, 1, 2, or 3. And once again, we'll just try to follow the notations that we had. What are the results? Well, let's take a look. If first, what is that we get? To answer the first question that we had, we have to keep in our minds every single time that we repeat the process, right? Let's say that we are at 0, right? And we read a B. By reading a B, well, we would land at 2. Being at 1, right, results in nothing, right? There's nowhere that we can go. Being at 2 results in 4, and being at 3 results in nothing. Okay. And then we ask the same question. Well, now that we are at any of these states to which we transition, being 2, 4, where can we go from there without reading anything, right? By following these epsilon arrows. Well, let's summarize that. We have that from state 2, which is just indicated here, we can stay at 2. And that's all that we can do. Now, from state 4, we can stay at 4, or go to state 3. So let's put it in a summary. Thus, from either 0, 1, 2, or 3, we can go to 2, 4, or 3, right? Which is, of course, put it in a set notation to the set 2, 3, 4. Again, this one is going to be a new state that I'm going to signal here, just below this portion that I'm just marking here down, and it would be 2, 3, 4. Now this state is supposed to be final because it contains a 4, so we'll just mark it down as a final state. And in this diagram, we go there by reading a B. Okay, now we're done processing the state. We only have the symbols A and B, right, to begin with. Let's now see what happens. We're just going to repeat the procedure, right, with this state that we have here, right? We're going to look at the things as the possible states that we can land by reading an A. Well, let's see. Let's see what we can do. So now let us process the state recorded as a set 0, 1, 2, 3, 4. Of course, I don't write it in full set notation within the circles or inside the ovals defining the states of the new machine, just to simplify the notation. But we're dealing with a collection of states that we can land, right? That's interpretation, right? And note that if we read A, we know already now at this moment that from 0, 1, 2, or 3 we can land at 0, 1, 2, 3, or 4, right, which is the state that we have, only because of the previous step that we just performed, right? Now, you may say, well, this covers everything in the collection, right, except for this state. But from that state, let's see what happens. If we read an A, well, there's absolutely nothing that we can do. But you may jump to 3, right, by following an epsilon arrow, and that indicates that you can go to 3. But that's already within the collection that we have here. So that means that we actually have a loop, right? So from 0, 1, 2, 3, 4, we go to 0, 1, 2, 3, 4. Reading A. Okay, so I'm going to indicate that as a loop here. Okay, second thing, well, let's see what happens when we read a B. So now, from the state 0, 1, 2, 3, 4, upon reading a B, we have, well, let's try to summarize that. We have, well, from state 0, we read a B and we can go to 2. From state 1, we read a B and, well, we get nowhere. From state 2, we read a B and we go to 4. From state 3, we read a B and, well, we do nothing. From state 4, we read a B and, well, there's nothing that we can do. Oh, okay. So that means that among the things that we can do, we can land at 2 and we can land at 4 by reading a B. Now let's take care of the things that we can do by reading nothing from those states. So we have that from 2, right, we can stay at 2. And from 4, well, we can stay at 4, or we can jump to 3. Okay. Well, let's summarize all of this information. That means that, well, by collecting things, we have that upon reading B, we can go to 2, to 4, stay at 4, or sorry, stay at 2, stay at 4, or jump to 3. Well, that corresponds to the following. From the state 0, 1, 2, 3, 4, meaning from either 0, 1, 2, 3, or 4, we go to either 2, 3, or 4, right? Upon reading a B. Well, how do we signal that? That's an arrow here. Here we have our B. Okay, well, we're done processing this state. Now it's time to process this one, right, and see what happens. Okay, so one more time. So now, to process the state 2, 3, 4, well, let's see what happens. Now I think we can organize it in a little more efficient way, and I can say read A from either of the ones that are indicated here. Well, what happens when you read an A? Well, from 2, you read an A, well, there's nothing that we can do. From 3, if we read an A, we can go to 4. And that's, I think, all that we can do from that. From 4, if we read a 2, if we read an A, I'm sorry, then, well, we would land nowhere, right? There's nothing that we can do. And now, well, let's see what happens from the collection of things that we can land. What happens when we just jump? By what can we do by reading no symbols whatsoever? So from 4, we can stay at 4 or go to 3. Okay, so how do we signify that in a collection, right? How do we signify this as a transition? Well, this says that, well, by reading an A from any of these states, we would be landing at either 3 or 4. Okay, so I'm going to build that as a new state right here, the state 3 or 4. Now, this one contains a 4, which is a final state of the original machine, so this one is going to be a final state of the new machine, as we're following this emulation. And we just signal it here. Okay, we're reading an A. Now, what happens if we read a B? From any of the states that were listed here. Well, let's see. If I have a 2 and I read a B, I can go to 4. If I have a 3 and I read a B, I go nowhere. If I go to 4, right, and I read a B, well, I get nowhere. Well, but from 4, right, which is the only thing that we can land to, right, from any of the states that we have here, we can do two things by reading absolutely nothing, which would be stay at 4 or go to 3 from the original picture, right, that we have to keep in mind. Well, that means that upon reading a B from any of the states that we have here, we can either go to 4 or to 3. But that's already indicated as a state here. So that means that I'm going to simplify this by indicating just a comma, right? Because now from either 2, 3, or 4, we would go to either 3 or 4 by reading either A or B. Good. So now that's going to lead us with a single and essential final question, right? Which, well, perhaps we don't know. What are the things that we get by reading? By considering and processing the state 3, 4, right? Well, let's take a look, just briefly, and I'll put it as an additional marking here. Let's see. We may have to return, but we'll see. Okay. So now, from the state 3, 4, let's organize it. Let's say that we read A. Well, if you read an A from 3, we go to 4. If we read an A from 4, we do nothing. And how do we know that? Well, we can just go back to the diagram that we just had over here and analyze it in just a few seconds, and we see that that's exactly what corresponds to that case. Right? Now, the second question, now that we are at 4, right, what can we do, right, from that one? Well, let's see. Now that we are at 4, we can stay at 4 or go to 3. Okay, so upon reading an A from any of the states that were listed here, we can either go to 4 or to 3, but that would be indicated in a loop in this diagram. There we go. Now, we're done processing what happened when we read an A from any of the states that we have here. What if we read a B? Well, if we read a B, it would be from 3, nowhere. From 4, nowhere. That means that we go nowhere. That's the signal for a sync state, right? And how do we denote that? By introducing the empty set, right? In other words, from the state 3, 4, upon reading B, we go to a sync. And well, what would that be? Signaled by the empty string, by the empty set, right? An empty collection. And how do we place it in a diagram? Well, we'll go here, introduce a new state, which is a sync, right? And that's what happens when you read a B. Okay, we're done processing the state 3, 4. The empty set being a sync state, well, that's even easier to process because we're not supposed to exit that one once we get there. And that would be the final thing to do. Okay. And with this, we finish with this example where we provide kind of like a mechanism to transform a non-deterministic finite automata to a deterministic finite automata. And, well, let's not forget what are the 2 questions that we have to keep in mind every single time that we're processing the states, right? From any given state, what states can be reached reading a single symbol? And once you answer that question, right, looking at the places where you land, upon reading a state, landing at a state, what states may be reached without reading any symbol whatsoever? In other words, that allows you to process the epsilon strings, right? Or the epsilon arrow that you want to consider. Okay, well, with this we finish the second part, and I'll see you next time.